Next one. What is the slope of VT graph?
Acceleration.
Yeah, good. So we go VT graph. Yes. VT graph. Velocity time graph. It's called velocity time graph. What VT graph gives for us? In a VT graph, the area below the curve gives what? Any guessing? Area below the curve. You take any curve. Area below the curve gives what? Think. And it is answer available with your difference. That's why you want to study. And your return statement. Area under the curve VT graph gives displacement. Gives displacement covered in a particular time. How much displacement covers in a particular time? Displacement covered in a given time. In a given time. This is called very important. Displacement covered in a given time. Displacement covered in a given time. VT graph. VT graph. Finished? Yeah, before going today's specialty. Today World Standards Day. What do you take? World Standard. We use standard, right? For everything we have standards. We follow some standards. So today is World Standard Day. Which is related to physics. Related to physics. We have standard values. We take acceleration due to gravity. Some standard value. What value? Acceleration due to gravity, G value. How much we take on Earth?
9.8.
Yeah, we take G equal to 9.81. Unit? Yeah, you should not miss as unit batch. Meter per second square. Standard on the Earth. Okay, and even standard we take, right? For example, 1 kg is equal to how many grams? 1000 grams. This is a standard. And if you do speed of light, what's the value?
3 into 10 to the power of 8.
Yeah, this is called speed of light. 3 into 10 to the 8 meter per second. Standards. Everything are standards. We are right. We have very shared. We go small, medium, large, extra large, double XL, triple XL. So standards. For respect to size, we have a shoulder length, arm length, everything. So standard. So that is the importance of today World Standards Day. World Standard Day. Okay. So now you know. Now tell me, what is the use of VT graph? Why you need to study before going to graph? What uses here? There must be uses, right? We won't purchase anything. Anything we won't take unless there is some use from it. Correct? So what is use of it? To study, first use, right? To study the nature of motion, how motion happens. To study nature of motion, how motion takes place. Whether it is a rectilinear motion, or whether it is non-uniform motion or uniform motion, that we can check by VT graph. Velocity time graph. Next, to find velocity of component at any time, even required to find velocity at any time. Why? How can you find at any time? Because one of the axis is time. At any time I can measure. At any time I can get this. Next. To derive motion equations. Very good. To derive motion equation. Can we example for motion equation, please?
This is equals to VT plus.
Yeah. This is Sapeksh's favorite equation. Yeah. This equal to VT plus half AT square. Okay. But if it is falling, getting point. This equation told okay, correct. But if an object falling under the gravity, what equation then?
G A is equals to.
We replace A by G and become negative. Right? Yes or no? Now, what are the two more equations here? V square minus U square equal to 2AS. We have to derive this one, okay? One more.
V is equals to U plus.
U plus 80. These things we have to derive. One is fixed for exam. Any one direction they compulsory get for exam. And the direction we are doing based on VT graph. The last point, last application or uses of VT graph to find displacement and acceleration. What to take? To find displacement and acceleration. And acceleration. Okay, now we got uses. So comfort now, right? So you have to play at right? Anything we take it, we ask first, what's the use of it? If we need yearly required first, we'll take it. Correct? So these are the benefits. I repeat first one, VT graph. In VT graph, they curve. Okay, I'll draw curve. What a curve? For example, I'll take it like this. If you draw a curve. Okay, this area under this curve. This what gives displacement covered in a given time. This you take it as velocity, this you take it as time. And make sure always whenever representing the coordinates, you have to represent along with the unit. Like t means in terms of second under bracket. Velocity means meter per second. Along in a bracket I mention unit. Don't miss units. If you mention units, right? Okay, you are perfect. You are in, okay, that means that you are doing following some, okay, we are following set of standards. Got my word? Yeah, this is important. Unit you have to mention under bracket. So everything area under curve gives displacement covered in a given time. This is a T1. This is a T2. Within T1, T2, within this time, how much displacement covered? That gives by VT graph. Then what slope gives? What is slope here? In VT graph, what is slope here? I told slope equal to dy by dx. Correct? I told last class. Slope is equal to dy by dx. D means difference. Y means here I'll take here. This is y1, y2. This one I'll take in terms of t means dy by dx I'll take. Okay, dv by dt will take. Anything is okay. This is again x1, x2. Visible now? Yes. x1, x2. So what I take was slope here? Slope equal to dv by dt. Good? dv by dt means what? Acceleration. But the slope gives instantaneous acceleration. Instantaneous. What instantaneous? Minimum time. Yeah, time greater times in the slope velocity. Right? Which time we want, at the time we can get acceleration. This is the slope. Instantaneous acceleration. The slope in an VT graph gives instantaneous acceleration. Hope note okay in this one. Any doubt? Please feel free to clarify. Any doubt in this slope? Shall we go next? If you can draw this. Yes. For you, it's okay. Slope. This positive or negative slope? Which is positive or negative slope here? For this curve, slope I mentioned. Which is positive or negative?
Positive.
Positive slope. Good. Which is positive. If you draw like this, sorry, which is negative slope. What more? Negative. Why negative? Because this distance we take. Fine? Can I rest? Finish?
Yes, sir.
Next we go curves. I mean, different graph of VT graph. Type of motion, VT graph. And a lot of discussion with this V, whether velocity is usually small v or capital V. Lot of discussion going on this. So some textbook they use small v, some textbook they use capital V. But capital V we use for volume. Keep in mind, volume notation we take capital V. Whereas velocity, specific volume, we take small v. Got it? So how to represent? Just keep a small, it carrying an umbrella. Small v carrying an umbrella, right? In India, right, one state carries umbrella every time. Which state? If you carrying umbrella, you can directly identify. Yeah, he is this person from this state.
Tamil Nadu.
No. In India, West Bengal. Bengalis carry umbrella. Bengalis. You know, right, our the great freedom fighter, Subhash Chandra Bose. He was Bengali, but he was carrying umbrella even to his ICS interview, Indian Civil Service at the time. He was the first person, okay? And first we have one more person, Satyendranath Tagore, but he was the person who struggled at written exam and he was boldly faced interview. Subhash Chandra Bose, ICS with the highest rank. Indian Civil Service during British rule. He was carrying an umbrella. One question for you, take it out of the box. Why umbrellas in black in color? Can you check, right? Old umbrella. Nowadays you got advanced color, Geomart umbrella you got. But maximum umbrella you check, they are black in color. I want solid reason. Go through it. Aram se go through it. Tomorrow you come with that.
Black body radiation, light to black, absorb.
You think Maharaj should take time. Okay, why umbrella? Can you see, right? Umbrella and accent black in color. Nowadays you got color, pink color, red color. Huh? Why umbrella is in black in color? Which is again related to your famous physics. Yeah, related to our physics world. Yeah. So done. Type of motion. You go graph. Now let us take, I'll take a graph. Always y-axis velocity with respect to unit is meters per second. And s should be small. S must be small. Don't use capital. Capital S indicates what?
Distance.
Capital S indicates what?
Displacement.
Displacement. And even in thermodynamics, we use capital S for entropy. Started? Thermodynamics in college? Okay, we come to that. So, then this is time. Time in seconds. Let us take a VT graph where it having initial velocity u. Initial velocity u. We'll take initial velocity u. Why initial velocity u? Anyone? Why take u for initial velocity? Huh? Why can't take a initial velocity?
Before V, you will come alphabets.
Okay, very good. One more question. U will alphabet. Okay, U, V, W. First comes U. At the same time, we take different velocities in different directions. Velocity along its direction, we take U. Velocity along y-axis, we take V. Velocity along with z-axis, we take W. This is in vectors. Motion in plane. Motion in plane. This is very much required. Got it? So x in y, because you should differentiate, right? This should be differentiate. Here this is x-axis, this is y-axis. Motion along we take one thing, one notation, other notation, one thing. U, V, W. Why U, V, W? Why not P, Q, R, S? Get your point. See, every notation not decided based simply. They decided that's why because what standard is fine. I'm discussing that. Why U, V, W? Why not P, Q, R, S or P, Q, S or P, Q, R, S, T, U, V or M, N, O? There are many alphabets here. 27 alphabets here. Any series I can take. Correct? But why taking it only U, V? U, V, W. What next? X, Y, Z. It has to match series. When you unfold it, you should get series. U, V, W, X, Y, Z. Got what? So that is the reason we follow some standards. You really have because you just search in textbook, you won't get these things. Okay? Yeah, good. Go for it. So next, I taken initial velocity. Now, with initial velocity, I'll take our velocity V. Final velocity what we have? We take V. Okay. So what type of motion is? What type of motion is? From this you can check. So this is a motion with initial velocity. U. Motion with initial velocity U. Correct? Listen, I'll give time for it, please. I'll give time for it. Please drop your pens. Here. Motion with first point. Motion with initial velocity U. Correct? Yeah. Now tell me, this motion in positive direction. This motion is in positive direction. Positive direction. Correct? Motion in positive direction. Next one. What about acceleration? Motion in positive direction. I'll let here. With, look at this one. Positive. Perfect. Correct? How it work? Positive acceleration. On what basis?
Slow.
Perfect. Based on slope. This is a positive slope. Or I can take one more word. Positive acceleration. With the initial velocity U. Initial velocity having. If you start from 0, I can take no initial velocity. It was started at the initial velocity u. Got my word? Hope no doubt. Sure. Shall we go next one? Okay, if you go next one, you come to know difference easily. This is first one. Second graph. Second graph, I'll take same. You draw same diagram one. Don't draw smaller one. I have section in less space. My axis meter per second. This is same initial velocity. Same initial velocity. But this time, I'll change the color. What I mentioned, we start from here, I'll start from here. This is something as U. V. Now, what are the conditions? This is common. This is common taken, right? Initial is available?
Yes.
Initial is available? Okay, next.
Negative direction to negative acceleration.
Yes. What do you have? Negative?
Direction.
Negative direction. Negative direction was direction. Negative direction. Slope is negative, but movement is positive. I'll tell you why. See, it is positive. X-axis, right? Motion in positive direction. Motion in direction is positive. Like this moving, right? This x-axis it increases, right? For example, the velocity here is let's say 2 meters per second. If you go here, what value? Increases, decreases. It becomes rises, right? This is 2, this is 3, you go 4, so on. Correct? Direction is positive, but slope is negative. Yeah. With what you?
Initial.
Clear? You got difference in these two? Sure? Okay, go for it. You should identify very carefully with the slope and direction. Don't confuse the direction and slope. And even you can check. I'll clarify one second. Here, let's imagine I have some velocity value here. Okay? And this is velocity you find here. With velocity here. This is velocity value, right? So, reservoir I have 10 meters here. If I take here, velocity is increase or decrease? Let's check here, 20. Rising. That's right, positive velocity. I should take here, not there. I should take here. This is velocity axis, right? So, same. 10, 20. Check. Same, positive velocity. That's why, positive direction. Here, positive direction. What about slope? Negative. Hope no doubt? Because if you know these things, we can go motion in plane. Type of motion. Done? Yeah, next. Let's do. Same. This is V in terms of meter per second. Time in seconds. V meter per second. Time is seconds. We go motion. Understand? 0. Understand? 0. Now, as you show negative direction, positive acceleration. How can you show? Or negative direction, negative velocity. Negative direction, negative acceleration. How can you show? Can you guess? I give a hint. Here. You want to show negative acceleration and negative slope. First, we have to mention initial velocity u. Initial velocity u are shown. Okay. Now, if I draw a line up to v, now tell me which type of motion it is. Negative. Why? Why negative direction? Suppose the value, okay, here take velocity initially, here velocity will be minus 10. If here take minus 30, value increased? Decreased. So that's why negative direction. What about slope?
Negative.
Slope will be
Negative.
negative. Why negative slope?
Because it is in the plane of
Which quadrant? Which quadrant falls? Fourth quadrant. Fourth quadrant y is negative. Correct? So slope equal to dy by dx. If y is negative, numerator negative, enter negative. So we'll take negative acceleration. Correct? With what? With added minerals. ನಿಮ್ಮ toothpaste ಉಪ್ಪಿದೆ. Okay? With your toothpaste is charcoal. You have charcoal, right? So with initial velocity, ನಿಮ್ಮ velocity initial velocity ಇದೆಯೇ? 12 In your motion, do you have initial velocity? Yes. Good. Make a note of it. Next we go. We'll finish making a note of it. If you had doubt, please clarify. Hands please, influencer. Next. Which type of motion I can show? Next. I think almost we done. Different I show. Be unique. Yeah. For that, something different. What do you think here? Tell me. Here to here. This is called initial velocity u. This is the biggest, larger initial velocity. Okay, and it moves like this Obviously, that's be up to this is positive. Then this negative. That is called it changes its direction. Changes its direction at time t1. Changes its direction at a time t1. Slope positive here, slope negative here. First quadrant. Which quadrant? Fourth quadrant. And this last one I did as what I call minus v. Final velocity is negative. Final velocity is negative. Initial velocity is positive. Final negative. ಹಂಗಂದ್ರೆ ಈಗ ಹೋಗೋದನ್ನ ಹಂಚ್ಕೊಂಡು ಓಡೋಕೆ ಬರ್ತದೆ. ಏನು ಮಾಡ್ತಿರ್ತೀವಿ ಹಂಚ್ಕೊಂಡು ಓಡೋಂಗೆ ಮಾಮಿ ಏನು ಓಡೋದು ಮನೆಗೆ ನಿಮ್ಗೆ ಗೊತ್ತೇ. ಸೊ ಲೈಕ್ ದಿಸ್ ವೈಲ್ ಗೋಯಿಂಗ್ ವಿ ಮೂವ್ ವೇ ಕಾನ್ಫಿಡೆಂಟ್ಲಿ. ಯಾರು ನೋಡ್ತಿದ್ದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಓಡೋದು ಮನೆಗೆ ಓಡಿರ್ತೀವಿ. Negative velocity. Got it? So, this one. Better? Negative acceleration. Negative acceleration change in velocity with respect to, change in direction, right? Change in direction. Change in direction with respect to what? Time. At what time changes direction? What? T1. Whenever it comes right at the Doppler effect. T1. With ನಿಮ್ಮ motion initial velocity ಇದೆಯೇ? Do you have initial velocity in motion? Yes. With u. U for? U for umbrella. Correct? U for umbrella, one more? U? Only umbrella? Check one more. At least two I want. U for umbrella, one more? U for unit is different, okay. But something should, in product should show. U for umbrella, U for umbrella, 1, 2, 3. U for uniform. U for uniform. Next. U for umbrella, U for uniform. Make sure the product. Some product should be used. Okay, should be used daily. Opening won't come. It's pickle because. Then you see she say U for Upendra. Huh? What do you then? Use initial velocity we got here. But something after like someone asked, usually in a way to answer it. A for apple, A for ant, we say 1 and 2. A for aeroplane, we can say. But U for umbrella, U for uniform, U for. Take homework, give me 5 at least. Out of the box. Give me 5. Make sure you use daily. Okay, familiar at least, you're familiar with that. U for 5 examples. Finish what? Shall we go next?
Product 3, product 2.
Which are familiar to us. It may be anything. See, for aeroplane, we never went in aeroplane. But even aeroplane familiar to us. We not use daily, right? We use daily aeroplane? We don't use. But it is familiar to us. And we use X for xylophone. We use a xylophone every day. We use only mobile phone. No one is xylophone. Right? So that is familiar to us. Something, okay, it's very interesting. Done now?
Yes.
Yeah. Next one, we go motion equations. Yeah. This motion equation for exams, there are two methods we have. One is graphical method, like this. Next one, by derivative method. Okay, first we go graphical method. As time moves, we go with the next method. Type of motion bada. Beka. Derivation we go. Kinetic equation of motion. We go. Kinetic equation of motion. Right on? Kinetic equation of motion. Let us derive the equation. Let us derive the equation. Kinetic equation of motion. Kinetic equation of motion. First we go. I'll draw one graph. This graph is common to all derivation. And I'll do only one derivation. The remaining goes part. As a homework, not out of the box. Okay? Let us take two axes. Which axis are? Which is abscissa here? X is called abscissa. The abscissa? Abscissa. Y axis called?
Ordinate.
Ordinate. What do you call? Ordinate. These are the nickname. Pet name, nickname, surname. Okay? So, abscissa, ordinate. Okay? So now, we may ask a question. Sir, about like, why you taking x only time? Why you won't take y axis? We can take no issues. But it's comfort for us. But it is comfort. Okay? So, now, this, okay, for derivation, let us take with the motion initial velocity. Do you initial velocity in motion? Yes. With which was positive velocity, positive direction, positive acceleration. Very good. Positive acceleration, okay? Done. This is height. From here, what do you call this height called? Initial velocity, this is final velocity. Final velocity. The notation given to you. You can decide anything. Let's start from here, right? I'll take this as a A, this as a B, put a vertical line called C, one more vertical line, D. Okay. This is origin. O for? O for origin. O for?
Orange.
O for? Owl. O for? Stop. There's a limitation. So know your limitation. Okay? And we are studying from 10th standard only English. We can't enable to give at least 5. 5. Yeah, go for this. Yeah. For this, we go with the notations. Let us consider initial velocity u. Let us, okay, the motion having a. Let's u be the what? Initial velocity. Now, object moving with the initial velocity of u. Don't write and give time for writer. Don't write and give time for writer. Just watch the movie first. Yeah. So now. From here to here, something you should show. What is this? Fill in the blanks.
Time.
Perfect. It is for time. Nothing but t. Yes. Let's u be the initial velocity and v is final velocity. Very good. V is final velocity. Now, derivation. How to start? Everything done. We are starting problem. Okay? If self won't work, what to do? We start, kick start. We will go. What is it? Just we go, if self won't work, we'll start, kick start. If kick not working, the class. Allah class for correct. It's old bike. Correct? Last time what was it? दूसरा what was that? What will ultimately we try? Correct? So starting problem. So let us starting problem start with the slope. What is slope? Huh? As per graph. Slope ಅಂದ್ರೆ ಏನು? Slope. Take BC dy by dx. Slope ಹೇಳಿದೆ. ಮತ್ತೆ ಮರಿಬೇಡ್ರಿ. ಮರವು ದೇವರು ಕೊಟ್ಟ ವರನೂ ಹೌದು, ಶಾಪನೂ ಹೌದು. ಯಾವ್ದು ಮರಿಬೇಕು ಮರೆಗಿಲ್ಲ, ಯಾರು ನೆನ್ಪಿಡಿ. ಕರೆಕ್ಟ್. ಸೊ ಸ್ಲೋಪ್ ಈಕ್ವಲ್ ಟು dy by dx. ಯಾಕೆ ತಪ್ಪು ಬಂತು? ಓಕೆ. dy means
BC.
dx means
AC.
AC na? DC by AC. BC means what? Here BC is equal to, which is
Final velocity
BD minus BD minus
BC.
Sambaka. BD minus DC or CD. Okay. Next BD ಅಂದ್ರೆ BD.
Final velocity.
Very good. Correct. Was it? Minus.
Initial velocity.
Very good. Nice. DX means AC means AC is equal to OC Allah. AC is equal to OD. AC equal to OD is equal to T. Very good. Further, let us move. Then, what is slope here? Acceleration. Correct. If I don't, slope is nothing but what?
Acceleration.
Yes. Notation for acceleration? A for acceleration. A for elephant. A for ant.
E for elephant, sir. E for elephant.
All are present here. Good. A for aeroplane. Good. So now we take equation number 1. Equation number 1 we written as slope A is equal to BC means B minus U upon T. Finally I got AB is equal to B minus U. We rearrange the terms. ಯಾರು ನಾವು ಬೇಕಂತ ಪಡ್ಕೊಂಡ್ವಿ, ಯಾರು ಪಡಬೇಕು ಮನೆ ಹೊರಗೆ ಆಗ್ತದೆ. ಕರೆಕ್ಟ್. ಸೊ V is equal to U plus EAT. This is your first equation of motion. That's done. Hope you need no doubts. Good. The remaining two? Homework.